The photoelectric effect is a phenomenon in which electrons are emitted from the surface of a metal when electromagnetic radiation of sufficiently high frequency falls on it. This effect was first observed by Heinrich Hertz and later explained successfully by Albert Einstein in 1905 using the quantum theory of light. Einstein's explanation of the photoelectric effect provided strong experimental evidence for the particle nature of light and earned him the Nobel Prize in physics. When light falls on a metal surface, the electrons present in the metal absorb energy from the incident radiation. If the energy of the incident light is greater than or equal to a certain minimum energy required to liberate an electron from the metal surface, electrons are emitted. This minimum energy is called the work function of the metal. Different metals have different work functions depending on how tightly the electrons are bound to the surface. A very important feature of the photoelectric effect is the concept of threshold frequency. The threshold frequency is the minimum frequency of incident radiation required to just eject electrons from a metal surface. If the frequency of light is less than the threshold frequency, no photoelectric emission occurs, regardless of the intensity of light. This observation cannot be explained by classical wave theory and strongly supports the quantum nature of light. According to Einstein's explanation, light consists of discrete packets of energy called photons. The energy of a single photon is given by E equals h nu, where h is Planck's constant and nu is the frequency of radiation. When a photon strikes an electron, the entire photon energy is transferred instantaneously to the electron. A part of this energy is used to overcome the work function, phi of the metal, and the remaining energy appears as the kinetic energy of the emitted electron. This leads to Einstein's photoelectric equation, h nu equals phi plus k, where k equals 1/2 mv superscript 2 is the maximum kinetic energy of the emitted electrons. Experimental observations show that the kinetic energy of photoelectrons depends only on the frequency of incident light and not on its intensity. Increasing intensity increases the number of emitted electrons but does not increase their kinetic energy. This is a key NEET and IIT-JEE concept. The photoelectric effect has several important applications, including photoelectric cells, automatic streetlights, light sensors, burglar alarms, and solar panels. Thus, the photoelectric effect plays a crucial role in modern physics and forms a fundamental bridge between classical and quantum theory.